version control. In here, basically, I'm going to actually specify about JIT and SVN, which is also known as subversions. So, apart from these, there are other version controls available, but in here, I'm specifically concerning about JIT versus SVN, which is heavily being used on the industry level. So, as a starting point, version control, also known as revision control, or else in source control management system. So, in the industry level, sometimes you might hear as source code management system, revision control systems, or else it's merely a version control system. So, what is a version control? Version control is all about managing multiple versions of documents, programs, websites, etc. So as you can write down, definition can be a version control system is a system which allows for the management of code base. So the next question you might get to your mind would be, is it merely a code only? The simple answer would be no. It also includes documentations, README files, configurations, even the graphics, the PSD files, and etc. Which will be not a certain type of file. So it can be a combination of all types of files under one single layout. So what is the importance of a version control? It used to keep a repository of your project files together with the history of all your code changes in one place. So basically, it allows you to maintain almost all the files related to a particular project, in this instance, under one single place. Next thing would be, it allows the developers, specifically, of the project to track every change based to the code, who made these changes, when does this changes has been happened, and the reason behind each and every change. So as we all know that, even in here, in our company, even in the industry level, we all are working, multiple people are working on a particular project. That means, just like as we developers, as QA people, we all are working on a single project. So in this context, suppose as an example, developer 1 and developer 2 is there. You are going to work on, these two developers are going to work on same file system. Suppose file A, file B. So developer X will, in the morning, he will come and he will make some modification related to these files according to one particular development. In the latter part of the day, the developer Y comes in and he made some new development, new changes to the same file system. So at the end of the day, both these changes is being actually deployed to the file repository itself. So the next day, when these developers comes in, each and every developer should know what are the changes that he or she has been made, what are the changes that your subordinate colleague or the subordinate developer has been made, what is the reason behind that, when was this development or the changes have been made, and this whole thing need to be get to know. So these all things is being actually recorded in the repository level itself. Okay. So what happens if you are not using a version control? In here itself, in the early stages of our development, in the last year, as an example, on my career level, we were not been using this SVN. So the bad practices would be copying files here and there. Suppose you are making a file modification onto a file XYZ. Before you are making a modification, what you have been actually doing is getting a copy, taking a backup, and copying into the same location, which is a very bad practice. What will happen is, after a couple of period of time, your actual file system, it will increase the file system storage. That means there will be a pile of files, unnecessary files, which is been including on the same code repository, which are actually not need to be maintained. This will lead to unnecessary circumstances. Something like you might feel very hard to find the actual file. There are multiple backup files is there. So it's actually not a good practice to maintain a lot of backups on the same file location where the original file is being maintained. Next thing would be copy and pasting code snippet. Copy entire directory. Sometimes for particular development, you might need to actually copy a whole directory, the files inside a whole directory. So you are maintaining a duplication of the same file system, which is again increasing the storage and the media level. The next thing would be the most important thing, as we can say, email the code to developers and team members. As we can remember, in the early stages of our development, we are maintaining patches. When a particular developer maintaining development, start up a development and continue with that, and once he finish off with the development, the files related to that particular development, he created as a patch and send it over to the team or the deployment officer. What will actually happen is the deployment officer will have to again deploy it to the staging level, which is again a very tedious task when it comes to multiple developments are occurring on the same day. So these things can be actually simply eliminated by maintaining a version control or a version source code management system. As an example, when it comes to big code bases, practical difficulties in maintaining and handling large code bases. Simple examples would be Windows 95, approximately 5 million lines of code. In the Linux kernel 2.6, 40 million lines of code in the early stages of 2011. So as you can see that your whole code would be, there are a lot of files which is related to the development. The project would be very much high scale. So maintaining and managing the development for some extent would be very much tedious if you are not, unless and until you are not maintaining a proper version control and a source code management system. General details relating to the version control process would be: files are kept in a repository. Repository can be either a local or remote repository to the user. I will discuss it in detail later. The user edits a copy called a working copy. Every time in each and every, either it can be SVN or JIT or anything, every time the user, in here the user means actually developer, it can be developer, edits a copy which is maintaining as a working copy. You should understand that. Changes are committed to the repository when the user is finishing making the changes. Other people can then access the repository to get the new code. Can also be used to manage files when working across multiple computers. This I will highlight in here. Suppose a developer working in his office machine, working on a particular set of files according to a development on a particular project. Later on, once he goes home, he need to continue with his development. Whereas you might not maintaining your office, you are not using your office machine at that time. But still, you can access the common repository, which is being located in somewhere in a common place, and you can start up the development and continue through that, even if you are being in the home, at home or somewhere else. Right. So the version control types. Mainly, version controls can be divided into two things: centralized version control and distributed version control. What is the difference between these things? We will discuss that. Centralized version control is a single server or the code base. Clients in here, clients would be developers, QA people, even the project managers, tech leads, even the CEO level, the client as well, can access the server by means of check-in and check-out. Examples would be CVS, subversion, visual source set. These are the examples for centralized version control. Advantage would be easier to maintain a single server. The disadvantage would be single point of failure. What does it mean by single point of failure? Suppose your all the code repository is being maintaining on a single centralized location. Under a situation like server downtime, or else the network is not being available. At that point, all the developers will not be able to access the centralized code version control system using the he or she won't be able to access it through over the network. Under a situation like as an example, again I'm saying, under a situation like a server downtime, each and every developer won't be able to access the centralized location server, whereas you won't be able to continue with the development. So it's a holding back your own every task.
So we have a centralized version.
Yes. So distributed version control would be each client essentially holds a complete copy of the code base. This essentially means every time, suppose there are multiple developers, essentially when they are before they are starting up the development, they will be maintaining a local repository on their own machines, except for the distributed version. The repository is being located in somewhere else. Almost every developer maintaining a local repository on their own machines as well. Code is shared between clients by push and pulls. Examples would be Git, Mercurial. Advantages would be many operations cheaper, no single point of failure. As I have already explained, even when it comes to a downtime of a server, even when it comes to a network failure, still the code is being available in each and every developer's machine. Still they can continue with their development at the end of the day, or when the server is being again start up, or again the network is being available, they can commit the push the modification to the central remote repository.
So all the developers should download the Coursera
Yes,
local.
that is the essential of maintaining the distributed version control. Initially, each and every developer will maintain their local repository in their own machines. Right. So again, in here, as I am highlighting, I will concern about Subversion and Git. Subversion, SVN. SVN has been developed by Apache Foundation under distributed as free software under the Apache license. So it's been already available as free and open source. Each and every user can. It's available as a free software, not an open source. Each and anyone can actually use that. Developers use Subversion to maintain current and historical versions of files, such as source code, web pages, and documentation. The main goal is to the goal of using the SVN is, earlier people used the CVS, which is known as concurrent version system. The disadvantage would be there are a lot of ifs and buts behind the concurrent version system. The replacement or the successor point for CVS would be the SVN. Coming back to Git, Git is a distributed revision control system, as we all know. It was initially designed and developed specifically for Linux kernel development under 2005. Every Git working directory is a full-fledged repository with complete history, full version tracking capabilities, non-dependent on network access or centralized server. Going down, Subversion's major features over Git. Can you go down please? So, I will highlight what are the major features on Subversion over Git. One would be user interface maturity. As we know, in JIT, for some extent, JIT is being developed on the Linux kernel level, which is also a concerning as a command tool. That means almost everything which needs to be related to the JIT will be done through the command prompt, whereas the user interfaces relating to the GUI level on the SVN is far more mature than JIT. As an example, currently Subversion has wide range of user interface tools than JIT. Total SVN, Rapid SVN, this Rapid SVN is a cross-platform. Total SVN is specifically for Windows. For example, there are SVN plugins available for most popular IDs. Example, NetBeans plugin. There's an existing of NetBeans plugin. Single repository. Subversion only supports single repository. There is a little doubt about where something is stored. Once the user in here is again comes as a developer, either whoever a stakeholder who has been interested on this particular project. Knows the repository URL, they can reasonably assume that all the materials and all the branches related to that project are always available at that location. So almost everything will be available on a centralized location. Accessing control. Since the Subversion has a single central repository, it is possible to specify. We can create the groups, we can create the users, we can assign the users for these groups, and we can maintain the access control over each and every user. Partial checkout bandwidth requirement. With Subversion, you can check out just a subdirectory or repository, which is not being available with the JIT. This is the highlighted point, which is not being possible with JIT. For a larger project, even for a larger project, this means that you always have to download the whole repository. That, as I always said, that as an initial phase, each and every developer will maintain the local repository. Even for a larger project, each and every developer has to download a code dump or the code from the code repository itself. Even if you need to need the current version of some subdirectory, still you will have to download the code files. But again, in the SVN itself, suppose you require files relating to a particular subdirectory, a folder path, you can download it directly. JIT major features of a Subversion. JIT, the main one would be the distributed nature. So it will eliminate the single point of failure. Every user has a complete copy of the repository data stored locally. They are maybe accessing the file history extremely fast. That means whenever you are making, suppose now I am a developer, I am having a local repository on my machine, I don't have to actually looking into the files related to the remote repository. I can actually make modification into my own local repository files, which is far more fast than accessing the files over internet or intranet. So again, coming back to the access controlling, due to being distributed, you inherently do not have to give complete access to other people. Now sometimes some of you might know, in JIT repositories we are working on, generally the development comes under the development branch. Once it's been done, it will be moving back to the staging branch. So committing to the staging branch, you can specifically withhold to a particular developer, maybe a tech lead, on this extent, in this context. Performance. Speed is the most highlighted characteristic on JIT. Why? We are again highlighting the point. We are doing the modification on local repository itself. Right. So JIT is extremely fast since all operations except for the push and fetch are locally. There are no network latency involved for these things. Performing a diff merging. If there are differentiation between the file which you are being modifying with the original file, you can make the diff merging. Viewing the file history, committing the changes, these all can be accessing through the local files itself. You don't have to moving up and down through the network itself. So the small test requirement. This is one of the important part. JIT repository and working directory sizes are extremely small. One of the reasons for the small repo size is that SVN working directory always contain 2 copies. SVN will always maintain 2 copies, whereas JIT will only containing one single file for each and every original file. One for the user to actually work, now in the SVN, one for the user to actually work with and another hidden in the .svn folder. This is a hidden folder which is been behind the SVN. To aid the operations such as status, diff merging and committing. Next thing would be line ending conversion. If you go a little bit down, JIT can easily configure to automatically convert line ending to CRLF or LF. So the carrier return is /r, line feed would be /n. What is the difference between this? You might ask. Carrier return would be, suppose you have been running your file, you're running a what do you call the application. Carrier return will not move the cursor to the next line. It will once the execution is being made, it will be still holding on to the exact file line which is the last, which is being executed at the last. /n line feed would be every time the execution is being completed, it will move to the next new line, the next line under that. So depending on the native line ending used by the client's operating system. So these things are actually these conversion features is useful when Windows and Unix users are collaborating on the same set of source code. So this is one of the important part. Sometimes in the SVN we might also face this line ending conversion is a little bit tedious, whereas in the JIT it is supporting undoubtedly. Next thing would be source code hosting providers. Now, as I am saying that there are report repository where everyone can actually access the same repository and working as a set of developers. So, for the JIT, GitHub, Bitbucket, CloudForge and Assembler would be there. But again, most of the source code hosting providers will not allow you to maintain in a private repository. Private repository will be allowed once you are being making as a paid service. Some of the things, as an example, GitHub will allow you to maintain public repositories, but the only disadvantage would be it will be viewed and to the almost every user who is being available in the GitHub. That means your code is not being secured. It will be visible to almost every user. So whoever the person who knows the JIT repository link, he can download it without any doubt. If you are maintaining a public repository, if you are maintaining it as a private repository, as a paid version, paid service, you can maintain their security, high security upon that. For SVN, Assembler, CloudForge and CodeSpaces provide the source code hosting providers. Hosting providing solution. So this solves all the information or details has been got from Google, plus these are the reference line. You might also can look into that. So this is the end of my presentation. Thank you all.